Today, we'll be solving LeetCode 155, min_stack. First, we define a class called min_stack. Inside the constructor, which is the function named init, we initialize two empty lists. We set self.stack to an empty list. This will be our regular stack. Then we set self.minStack to an empty list, which will keep track of the minimum values. Next, we define the push method. This function takes in a value. So we say def push with parameter val. Inside the method, we call self.stack.append with val. This adds the value to the top of the main stack. Then we handle the minimum tracking. We check if the min stack is empty. If it is, or if val is less than or equal to the last value in the min stack, then we push val onto the min stack too. So we say if not self.minStack or val less than or equal to self.minStack at index -1, then append val to self.minStack. This ensures the top of the min stack is always the minimum. Let's move on to the pop method. We define pop with no arguments. First, we check if the top of the main stack is equal to the top of the min stack. So we say if self.stack at index -1 equals self.minStack at index -1, then we pop the min stack too. This step is important because if we remove the current minimum, we also need to update the minimum stack. After that, we pop the main stack by calling self.stack.pop. Now let's look at the top method. This one is simple. It just returns the last item in the main stack. So we say return self.stack at index -1. Finally, we have the getMin method. This returns the last item in the min stack, which is the current minimum value in the overall stack. So we return self.minStack at index -1.